Welcome to the TOEFL listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Professor Reed. Thanks for meeting with me. I wanted to go over the effects of ocean acidification for my presentation.
Hi, Miguel. That sounds good. Tell me what you already know and what you want to emphasize in your talk.
I know rising atmospheric CO2 is absorbed by the ocean, and that changes carbonate chemistry, but I am unclear about the biological consequences.
Start with the chemistry. When CO2 dissolves in seawater, it forms carbonic acid, which releases hydrogen ions and lowers pH.
So a lower pH means more hydrogen ions. How large has that change been so far globally?
Since pre-industrial times, surface ocean pH has decreased by about 0.1 units because the ocean has absorbed roughly 30% of anthropogenic CO2.
A tenth of a pH unit sounds small, but I have heard it equals a big increase in hydrogen ions.
Yes, that drop corresponds to roughly a 30% increase in hydrogen ion concentration, which affects carbonate ion availability.
Why are carbonate ions so important for marine life?
Calcifying organisms like corals, mollusks, and some plankton need carbonate ions to produce calcium carbonate skeletons and shells.
So if carbonate ions decline, it becomes harder to build shells and skeletons. Are all calcifiers equally affected?
No, sensitivity varies. Pteropods and some bivalve larvae are particularly vulnerable because they build thin aragonitic shells that dissolve more readily.
Can you give me an example where acidification caused real-world problems for fisheries or aquaculture?
Yes. A well-documented case in the early 2000s involved Pacific oyster hatcheries in the northwest United States.
What happened at those hatcheries?
Upwelling introduced CO2-rich water with low aragonite saturation to coastal areas, and larval oysters suffered high mortality because they could not form shells.
Was that caused directly by anthropogenic CO2 or natural upwelling?
Both. Upwelling normally brings deeper water with higher CO2 to the surface. Anthropogenic CO2 raises baseline PCO2, so those waters are now more corrosive.
So upwelling regions are at special risk because natural processes amplify the acidification signal.
Exactly. That makes coastal management and hatchery monitoring crucial in those regions.
You mentioned pteropods earlier. Is there field evidence of their shells dissolving?
There is. Researchers have observed pteropod shell dissolution in the Southern Ocean, where aragonite saturation states have fallen particularly low.
If pteropods decline, what are the broader ecosystem impacts?
Pteropods are an important food source for fish and whales in polar food webs. Their decline can cascade up the food chain and alter energy transfer.
Are there documented cases of such trophic cascades caused by acidification alone?
Direct cascades are difficult to attribute solely to acidification because multiple stressors interact, but experiments and long-term observations show shifts in community composition consistent with acidification impacts.
What about non-calcifiers, such as fish or seagrass? Does acidification affect them too?
Yes. Fish can experience altered behavior and sensory function due to changes in ion regulation. Seagrasses may benefit from higher CO2 for photosynthesis, but that can cause local pH changes and complex effects.
So effects are species-specific and context-dependent.
Correct. And we also must consider the capacity for acclimation and adaptation. Some populations show genetic variation that could allow partial adaptation over generations.
How fast can such adaptation occur relative to the rate of acidification?
That varies. Microbes and some plankton might adapt on short timescales, but long-lived organisms like corals adapt much more slowly and risk local extinction if stress is too rapid.
Are there mitigation or management strategies that directly address ocean acidification effects?
Local strategies include reducing nutrient runoff to limit eutrophication-driven acidification, selective breeding in aquaculture for resilient strains, and monitoring aragonite saturation to time-sensitive life stage events.
Do marine protected areas help protect species from acidification?
They help by reducing other stressors like fishing and habitat destruction, which can increase resilience, but they cannot prevent large-scale chemical changes in the open ocean.
For my presentation, I want to include a clear explanation of aragonite saturation. How would you define it simply?
Aragonite saturation describes how saturated seawater is with respect to the mineral aragonite. Values below 1 mean the water is corrosive to aragonite shells.
That will be helpful. Should I add a slide on regional case studies like the Pacific Northwest and the Southern Ocean?
Yes, include both. Use the Pacific oyster hatchery example for socioeconomic impact and the Southern Ocean pteropod observations to show polar vulnerability.
Anything else I should highlight for an audience of undergraduates?
Emphasize that ocean acidification changes chemical equilibria, reduces carbonate ion concentrations, and that those changes drive biological effects that scale up to ecosystems and economies.
Thanks. I will also note that buffering capacity varies by region, and that monitoring is essential to manage local impacts.
Good. End with a point about research needs such as long-term experiments, multi-stressor studies, and socioeconomic assessments to guide policy decisions.
Great. I feel much more confident now about explaining the mechanisms and real-world effects of ocean acidification.
You are welcome. Send me your slides and I will give feedback before your presentation.
Listen again to part of the conversation, then answer the question.
Upwelling introduced CO2-rich water with low aragonite saturation to coastal areas, and larval oysters suffered high mortality because they could not form shells.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.